Hey guys, so this video will actually dive deeper into the physics engine of Unity and how to actually use it on a base level inside GraalScript 2. Like for example, right now I'm moving and there are all these objects in the world, but this post, I can't walk through it. It's actually solid. But not every single object is like that. So for example, if I jump on this guy's head, the air is not solid. I can actually walk through it. Now, this video will dive deeper onto what are the colliders and how does the physics work in Unity and how it's translated into GraalScript 2. Hopping into Unity, let's start with the basic building block. Well, a cube. Now, as you can see on this cube in the inspector, you can see, well, the renderers are just like what the model looks like, which is cube render and everything, so it's not really important right now. What I want you to focus on is the box collider. So as you can see on the cube, there are these green lines, this green box. Now this is the collider. The dimensions can be changed, the width, the height, to match really, however we want it to be. And this collider actually tells Unity that this is a solid object. Now imagine putting in your own model. So let's keep it as a cube for now. Let's remove this component. So now because it doesn't have this collider on it, well, this cube will be invisible essentially, like this arrow that we've seen on top of the NPC. Essentially, a player or any object with a collider can just phase through it. So let's place back this collider again. So it's a box collider component. And yeah, now what to keep in mind for the box collider is specific properties. First, the center. So where the collider is centered. So if I want it to be shifted, let's say one away, I can. Of course, its size. So if I want to make it smaller, this would mean that only this part is collidable. So I can actually go into the cube, but I would stop at the center of it, where this actual collider is. And a very important boolean that is called is trigger. Now, what the is trigger boolean does, it actually transforms this actual object into an object that can pass through, but it actually sends in signals that, okay, something has been triggered. Someone has entered this area. An object has passed through this, well, area. Now, of course, there is a lot of colliders available inside of Unity. I would highly recommend checking it out. As in, there's a box collider, a capsule collider, a sphere collider, a polygon collider, and everything. The base changes are just how they look, how they're actually created, like the center, the size. For example, sphere only has a radius, and really those actual specifications for each type of collider. But all of them are essentially the same, is that they can be set, they behave the same way with the physics engine, and they can have this isTrigger boolean that can transform them into like a zone that can send events when it is entered in or exited or when it's still inside this actual zone. Now, something else that actually amazing about the engine is there's not only colliders that are actually in effect, but you can also add something called a rigid body. Now, a rigid body basically tells Unity that this object will use the physics engine of Unity. So, for example, it will work with forces, it will work with momentum, with speed, with mass, with gravity, with angular drag, with drag, and all. So, for example, right now we see this cube. It's like floating in the air at like 0, 0, 0. Let me put it in front of the main camera. And now if I hit play, we're going to see the cube falling because there is this gravity that exists. So if I go on the cube and remove the use of gravity, it will stop falling. Now, I'd highly looking more into rigid bodies by yourself, like understanding really how they work and everything, and just you can move it via code by changing its velocity, making it go faster. It's just a vector tree that would go in a specific direction, and however long this vector is, however fast the object will go. Simple enough. You can also add constraints. For example, you can freeze the rotation on X, so If a rigid body actually hits something with enough force, this force will be diverted into rotation. So if you freeze a rotation, it will never rotate in that axis. Freezing all rotations would basically mean that when you hit a wall, it will just stop that in its track or maybe bounce back. Just divert this force or energy from this rigid body somewhere else. So let's start with something very basic to display what we can do. We're just gonna easily just spawn a game object, a sphere. We'll call it my sphere so that it just doesn't duplicate and we still have just this my sphere inside the scene. So we can destroy it every time, just find it. And we're just gonna put the position just next to the player, like 20 steps away. So if I apply this code, yep, there is the sphere. Now, for GraalScript 2 to actually understand and work with the physics engine and actually the events that can be triggered from the collisions or the trigger zones, this .keepAlive must be set to true. If it's not, the events will not be called and you won't be able to actually treat the events. As an example of an event, imagine a trigger zone. Once the player enters this zone, we start healing them, and once he exits, he stops getting healed. Without this .keepAlive, this won't work. Now, first things first, we're gonna access the collider. So just as a show of what the trigger is, now if we take the trigger variable and we set it to true, if we hit apply, we can walk through the ball. Now if we set it back to false, hit apply, yep, it's still a collider, an object that we can't really go through. Now let's make something a bit more interesting. Let's give this ball a height and let's add to it a rigid body. So now when we hit apply, well, the sphere just falls and stop. Hitting apply again, it falls and stop. So now with this actual sphere rigid body and has been applied, we can really work towards it. For example, we can start with this dot sphere RB dot velocity equal v3. Let's give it a 1, 0, 0. When we hit apply, you can see the ball is actually moving to the left because of this 1. It has this small velocity. We can make it move to the right by giving it a negative 1. And you see, as it hits my player, this velocity is diverted because there was a collision. Now, it would be amazing to actually get events when collisions like this happen. So, the way to actually get these events is actually pretty simple. We're going to start writing these 2 lines of code that are really mandatory. So, Quattro event manager add on collision handler 2. Now, this will take 2 variables. First is the game object, so this dot sphere, and the game object layer, this dot sphere dot layer. This basically says that this dot sphere, when it collides with an object from the same layer as itself, because you can actually separate layers. For example, you can make bullets not hit the player layer, so it doesn't hit themselves, but just hit enemies or buildings, etc. And now we're going to write the second mandatory line of code. This will basically cache the specific event we want and actually send it to a custom function that we will write so it creates its own behavior. So the first argument will be the object that will generate this event, which is in this case this sphere. Then we're going to give it what event we want to treat. So in that case, on collision, enter. So when a collision happens, and then we're going to give it which function we want this event to be treated in. So let's say ball hit ground. So now when we write this function, it will take in 2 arguments, which is the game object, being the ball itself when it gets hit, and the collider, being which object it hit. Let's say, for example, just simple player.chat, ball hit something. And now when we hit apply, yup, as soon as the ball hits the ground, we do say ball hit something. Now through this event we can actually create a lot of different things. So for example, we can actually get the collider dot game object dot name, and when we hit apply for that, as you can see, it hit this part of the floor. Now we can check for that, for example, maybe hitting the player or hitting a specific other object. It can create some interaction. For example, we can just destroy it. Object destroy geo. Now when we hit apply, as soon as the ball will hit the ground, we're gonna say the name of the ground, and then the ball will be destroyed or will just disappear. So this is really how you can actually manipulate and create events for collisions from the actual game objects. Now something very important, every collision event, like on collision enter or collision exit, at least one of the two game objects that touch each other must have a rigid body on them to actually get the event to trigger. Now to actually get it working with triggers. So first step is to actually set the trigger to true. Then we're going to add not an on collision handler 2, but on trigger handler 2. We're going to take the collider dot game object. It can be done also from the sphere directly, but it's just for example showcase. But this time we don't want the sphere layer, we want the player layer. Because what we're going to do is the player is going to walk through it, and we're going to see him, well, walk through it. And actually do something when the player walks inside of the sphere. Now we're also going to catch events object, but rather than on collision enter, we're going to use on trigger enter. And now for cleaner code, let's just use a sphere collider.game object here. Simple enough. Now when we hit the, what we want to do, we're going to say player.chat equal I collected the sphere. Now when we hit apply, as you can see, the sphere just phases through the world because there is no longer a collider on it, so it won't be stopped by the ground. For that, let's just remove the rigid body and hit apply. Let's put the position of the sphere back next to the player and hit apply. And yep, now when we walk through the sphere, yes, the player does say I collected the sphere. Now, collecting a sphere bar is still there, so a cool thing to do is to actually destroy the sphere. So object destroy geo. Hitting apply, now we collected the sphere. Now imagine this system that once we collect the sphere, rather than just destroying it, we can actually have an inventory system or something that can give, for example, the player a new item that can be used for a quest or to open a new door, or really the possibilities are endless as you can create a zone. So rather than just destroying the zone, you can just get in and start healing the player. And when he exits, you can start, well, you can stop healing the player. And really the possibilities are endless at this point. So basically, this is how the basic event architecture works, and it is how it's interpreted with collision, physics, and the entire Unity system. Now, I would highly recommend just checking how this Unity system works in Unity, and this is truly how it's translated to GraalScript 2, how you can handle the events in GraalScript 2, how you can really change the parameters. If something is really unclear, like what are the parameters for the rigid body other than velocity, for example, you can just check the documentation to actually get them all right here. And if you have any questions on the subject or really something seems a bit confusing, I would really highly recommend just jumping on Discord, asking questions, and we'll be more than happy and really glad actually to help you out through your GraalScript 2 3D journey.